the third class of Big Data Analytics of autumn 2022. Right. So the first class, if you recall, we had sort of like a schematic or overall understanding of where the class is heading, right? The objective, like I stress, is for you to be able to sort of like put yourself in the shoes of a professional data scientist and sort of like imitate their procedures or their activities by tackling a small set of data that you can play with from the beginning to end, right? You also will have a test, well, not a bit more than a test, quite a bit of practice in practicing coding. Coding, again, this class will have two set of language paradigm, both of which are heavily reliant on functional programming way of communicating with your computer program. One is Mathematica, which we went through the bare bones sort of like introduction to Mathematica last week, and the other one is Python. And again, we talk about the difference in that, well, Mathematica has, you know, analytical capability that general language like Python or even R or, you know, C# or JavaScript, they don't have. They don't have the analytical capability. So, for example, you can't put in a function. It doesn't understand what infinity is. It doesn't do summation from I to 1 to infinity and so forth. But that is probably not so much of relevant to you in this class, in the sense that we are focusing on data analytics capability. What does matter is that a lot of data analytics functionalities is so, let's say, so common sense, you know, it's so routine, so common sense that in mathematical language, it's just wrapped in a higher level language as a functional. So you just sort of say, you know, bring this data set and try to find a classifier that best fits the prediction results and so forth. Right. Now, the introduction, so last class, let me just take 1 minute or two, talk about last class. Mind map, right? Which is an introduction here. Okay. Right. So again, this is the functionality. Now, the functionality aspect of it, let me move this thing around. Again, is centered around three things, right? The computational, like I said, the analytical bit is the hardcore mathematic, very abstract, something that you might not use that in the context of data analytics class, and also maybe numerical. You can think of numerical as a backup plan. If you can't do anything analytical, you can always use numerical engine, and in that case, Python can do it just as well, maybe even faster sometime with the optimized library. Okay, the functionality that should pertain to our class is the visualization capabilities. And we talked about, you know, how it can create plots and graphic in a very easy, high-level language. But at the same time, it also does support interactive or dynamic handling. In other words, you can have a moving frame. You can actually have a parameter that allows a user to interface, so like tweak buttons and so forth, right? And finally, what matters for us is there are two things that I highlighted as a strong point in application. One is machine learning and data analytics, which is very relevant to our class. The other one is using the analytical engine and also the numerical engine to solve optimization problem and system control. This is more relevant to engineers and economists and so forth. So this is not our emphasis here. I would be here, here, and a little bit of here, but not really. Okay, so here, and here are the capabilities, right? And then I mentioned that the environment here is, in terms of the computational platform, this is the bare bone Mathematica notebook. Again, the computational kernel notebook is going to be familiar with many of you who have learned some Python programming through Jupyter Notebook, because Jupyter Notebook was modeled after the Mathematica kernels. Okay, now after that, there's also like an internet resource, right? That shows you the archive, the publication, the demonstration, and so forth. And this is something that sometime when you're at a loss, you want to get a little bit of guidance, you don't have to ask me. You can explore that yourself. There's a lot of tutorial and so forth. Now, and there's this thing also called Wolfram Alpha that I mentioned last week. So it's a little bit like doing, Google search or Wikipedia search, except instead of searching over a static page, you search over some topic, and that topic has a data set associated with it. So last example, we considered, what happened when we just asked Wolfram Alpha information about Thailand. So it just brings up, sort of like a standard page, just like in Wikipedia page on Thailand, except instead of having just a static dry page, you have an interactive page. You can actually click, you can download data, you can play with the display, play with the axis, look at the Thailand's maybe population over the past 5 years, and then extend it to further back up, all kind of stuff. So basically introducing the data and make it computable, right? And finally, the thing that I asked you to go explore over the weekend was that it has kind of repository. This would be equivalent to something like GitHub. It's just a resource of things that you can use to bootstrap your project. So you don't have to start from scratch. So obviously the first thing is a repository of function, and that's the basic functionality within Mathematica. So it's huge, right? It's like thousands of high-level functionalities, analytical and numerical, and so forth. Then the second and the third is what I'm going to ask you to focus on, especially the second one, which is last week's homework, right? To go through the data repository and think of it as a curated and very homogeneously interface access to a huge database. So if you go to like Kaggle, it's sort of like an open platform. So whoever creates the data and curates it has its own style or flavor or mannerism and so forth. Whereas here, all the data in the Mathematica repository will be curated and will have a uniform interface. So, for example, you can have some basic function like asking about basic statistics and check out the histogram and so forth, right? And you can do this across all data set. And your homework, even though some of you were not here due to COVID or whatever, was to actually go through that and pick a data set you wanted to work with for the semester, for the term, okay, as your project. When working on that, chances are you are going to do, you're going to do data analytics on it. What do I mean by data analytics? Well, a lot of it would be visualization, again, interactive visualization. A lot of it will be modeling, like building a classification model, building a prediction model. And for those kind of analysis that requires basically computer or machine learning algorithm to perform, you can start from scratch, okay, using some of the built-in function, like, to build a neural network, or you can go to what's called neural net repository. These are complicated, big neural network or big machine learning model that has been pre-built. Okay, some of these, these are not built by guys in Mathematica. These are built based on current research in machine learning and AI. So you can imagine that, let's say somebody publishes a paper that comes up with a new machine learning algorithm in 2022, right? Then someone will implement this. Well, obviously, somebody will probably start implementing this with Python and maybe R. Well, the implementation of that in Mathematica will be archived in the neural net repository. Okay, and it comes in two flavor. The bare-bone architecture, in which case you actually have to train the model yourself, or the pre-trained model, in which case it already trained with like a standard set or global set of data, And if you want to apply to your data set, you can train some more. This is called transfer learning. We'll talk about it later. Okay. This is something that, by the way, is you know, it's a bit funny to you. It's completely natural way of doing things, but from people of earlier generation, this would have been sacrilegious. You know why? Because people who grew up from the statistical analysis era, they have this idea of a complete homogeneous batch. So there's no such thing as training the model to learn a little bit and then add a little bit more of data and then retraining it. Okay, that would fall under what's called Bayesian statistics. And believe it or not, at one time, Bayesian statistics was not accepted by mainstream statisticians. Okay, it was kind of like on the fringe. Yeah, you were kind of the weirdos if you were doing Bayesian statistics. Whereas, you know, nowadays, this kind of just starting a model with a set of data, you add more data, you don't have to throw the old set back away. You can just add more data and further tune the model. This is completely natural. This is completely natural, okay? Whereas, you know, 20, 30 years ago, if statisticians were to do this, they'd be labeled weirdos. Well, not weirdos, Bayesians, okay? But I like Bayesian statistics even back then. So I'm completely happy with this. Right, okay. So let's go to today. But before I go to today, I want to give, last week, we didn't have time to go over some of the Wolfram Alpha examples. So I thought I just throw that in. I use this for sort of like a summer break class, pre-class as well. Remember, if you click anywhere on the page, you should get this a plus sign. If you enter something, it becomes a mathematical expression. A is equal to 1, right? Shift enter, then you assign A. But if you want something else, okay, you can do this. Click the plus sign, or you can remember the shortcut, okay? So for the plain text, you can use Alt 7. For external language, use a greater than sign. Okay, so remember that equal, and then greater than and then Alt 7. So if you I think you had a student earlier who for some reason couldn't find the plus sign. I think it was in Apple or something, in Macintosh or something, right? So greater than would what? If I type in greater than, that would give you a prompt for external language. In my case, the external language is set up to Python as a default. I think you can configure it so it goes to R or whatever language. Okay, so that's if you want to do Python command within here. What else do we have? Alt 7, right? Alt 7, what's Alt 7? Alt 7 just around, oops, sorry. Alt 7, where's my Alt? Okay, Alt 7. Okay, that's just a text. Okay, nothing happened. Shift enter, nothing's happened. It's a text. Now, the fun things was equal and double equal. Again, this is not operation. This is just a prompt. So equal means you're still trying to do mathematics. You're still trying to do mathematics, but you don't know the formula. So you try to put in some English language a command like Siri, and Mathematica will try to do what you want. Okay. So what I want to do, I want to plot, say, a sine wave. Okay, say something like this. Okay, and then shift enter. It's gonna think about what you want to do and try to interpret. And oh, is this what you want to do? Okay, plot, open bracket, evaluate sine function from, say, some number. Okay, so if I already knew how to do this, okay, I can just use this. I can just enter this. Okay, but you had that interpretive sort of AI layer, so that if you don't know any better, you can just type in what you want to do. It's okay, but it's not that powerful. It's just interpretive. Finally, the double equal sign, you go equal. Okay, it becomes this thing about Wolfram Alpha. And again, Wolfram Alpha treats object as computable object. Whatever that object comes with, if it's a country, it comes with economic data, geographic location, map picture. If that entity is a person, okay? So I think example I was playing was, for some reason, I was thinking Buzz Aldrin. So equal Buzz Aldrin. Okay, obviously Buzz Aldrin will not have a geographical or national flag, right? So I shift enter, and it will say, okay, let's try find something about Buzz Aldrin. And okay, it's assume, just to confirm, Is this what you're talking about? You're talking about Buzz Aldrin, right? His name, date of birth, blah, blah, blah. Oh, he's got some picture, some notable facts, some, so obviously as a human being, there's not too many quantitative information. There's a lot of timeline, right? What his space mission were, blah, blah, blah. There's a little bit of Wikipedia page history. This is kind of like how often he gets hit, for example. So if you put in somebody who's more in the news lately, maybe this thing will spike up. Okay. So I think that was the example that I think I wanted to play with just before we go to visualization, which is a subject for today. I think I prepared something here. There. Okay. So, oh yeah, I think it was a global warming. Shift enter. So it clicks, obviously global warming, unlike Buzz Aldrin, is going to have a lot more numerical statistics to play with, right? So, okay, it plots a few things, it assumes. So these are kind of heuristic first go-to page, right? If you want to study global warming, well, obviously the first thing you want to do is something about temperature. So maybe there's a temperature, and this being interactive, just like what you're going to learn to do, you can play around. Okay, last 100 years, or maybe how about last 100 years, last 10 years, okay? And it does take, there's a little bit of lag here, I think. Okay, right. So annual, or okay, let's say 1,000 year. You want to show temperature. You want to check this out. So these are all data set. What's good is that this become a data set that you can play with. Obviously, see, this is kind of like this is the long 1,000 year temperature global record. Obviously, we start having more frequently tabulated or more frequent recording in the past 150 years. Okay, but before that, you can get this, and this, some of this came from ice sample and so forth. And it does give you the source as well, so you can go back and chase them, and so all kinds of stuff. And finally, oh yeah, you can do things like this. If you want to go to Wikipedia, you don't have to go outside. You can say Wikipedia data, right? And so in this case, I just want, like, go to Wikipedia page and take out our first few sentences. So this would be a Wikipedia data. Again, the object here is a variable, but this variable is a computable object. So you don't enter X, you don't enter Y, you enter Buzz Aldrin, the person, Buzz Aldrin, the astronaut, right? And you go to Wikipedia data. So right now, if you go to Wikipedia page on Buzz Aldrin, this will be the first two sentences. Okay, because this is text sentence for Wikipedia on this thing, and this is the access of the list. We talk about list access. So this is from the beginning to 2. So that 2 sentence. So if I want 5 sentence, so 7 sentence, I get more. Okay, obviously, right? And you can do all kind of stuff. Okay, this is another example. This is once you play with this. Once you go to Wikipedia, I couldn't resist. Well, let's check. Okay, Wikipedia data on Hamlet. There's an information set called language list, and I checked member queue. This is a query language, a query command. Just say, is there a Thai language version of Hamlet? Okay. At one point, I could recite off the top of my head, to be or not to be soliloquy, but I can't do it today. But certainly when I was younger, yes, we had to do something like that on stage play, right? So yeah, there's a Thai version, there's a Thai translate, so all kind of stuff. This is not alpha, this is not Wolfram Alpha now, but this were something that I might as well go through. So this is kind of graphical 3D style. I don't know what this is. How cool. This is just a graphic interface. Oh, I know what this is. I was giving talk to, I guess, incoming BuzzSci student, and trying to sell the idea that once you get to the programming, you can start programming graphical object in 3D, and then you can export it to a 3D printer. And we're building a make lab on the 4th floor. Okay, so it's not up, it's not up and running yet, but at some point, let's say you draw this thing up, you can send it to the printer on the 4th floor. It's actually donated by my brother-in-law, so might as well make a good use of it because he hasn't used that. And so this is elementary introduction to machine learning, and this is just to show you how high level things is. Okay, you would normally have to have like at least 15 lines in Python just to do this. But let's say you got pictures, right? You got pictures. Now this is very interesting. I'm not trying to recognize cats or dog. Okay, but I'm actually going to say that cats, well, obviously to your eyes, to human eyes, what can you tell me? There are three kinds of things now, right? There are cats, right? There are cars, and there are shares. Okay, well, feature space plot. Feature space is a technical, semi-technical term that means let's turn everything into vector. Okay, in other words, whoever you, oh, I forgot the name tag, so I can't call your name. So you, okay? I'm going to replace you with two numbers. I'm going to replace you with two numbers. I'm going to replace you with two numbers, blah, blah, blah. But based on certain characteristic, okay, that two number will be distributed in a two-dimensional plane in a way that corresponds to how similar you guys are. So if I look at you and what I take are measurement of your height and your weight, right? And yeah, your height, your weight, or whatever, right? And I want to represent you, okay? Obviously, I can say X is the height, Y is the weight. Then obviously you will be sitting closer to guys who are taller and heavier, right? Whereas if you pick you right there, okay, chances are you find yourself in the corner of shorter and smaller or lighter and so forth. Okay, well, that's 1-to-1, right? Height to height, weight to weight, right? Well, what if I say height, weight, eye color, sex, grade, GPS, history, where you come from, right? Date of birth, all this. And I want to say artificially, let's have some kind of artificial number that represent you. Two number, just like before. But these two number no longer mean anything. Except I ask the computer to say, based on how similar you are, profile, whatever it is, you know, sex, age, eye color, height, preference, ability to play piano, whatever. Okay. People who are similar should be similar. This function automatically is just going to throw you guys into a artificial two-dimension, and you'll find the people close to you in that dimension are similar to you in terms of height, weight, age, hair, eye color, history, whatever. Okay, so let's see if that does that. Except here, instead of taking a demographic kind of information, let's take information about the picture. See. So now what it does, it scatters. It put cars in a kind of here. It put chairs in the top half here. And you know, this is not that pretty. It's not well tuned. It's just a little example. But you can see that cats are together, cars are together, and chairs are together, right? And this is based on visual characteristic. Okay. So this would have taken, you know, by the way, you're going to get to learn Python from my own right-hand person, who's my project lead when I asked him, and he's going to do something like this, but obviously it's going to take, you know, 20 lines at least. This manipulate we'll do later. You have that. So that's today. Oh, this is the binomial theorem thing. Yeah, I guess. I don't know what this is. Okay, so these are just example. Oh, okay. Something about Thailand. Oh, just take some flag and then I don't know what that is. Oh, entity, chart label, country, entity. Oh, GDP. Okay, that's like nothing. Okay, this is sort of like working with real data. Okay, and right. I don't want to save that. Now, okay, let's get to the subject of today. Today, we'll do one and possibly two things. If you look at the syllabus, we'll start with the visualization, which is my here. Okay, visualization. And I don't know if I mentioned to you, there is a mode of marketing data analysis called data mining, like basket analysis. That is used very ubiquitously in all kinds of marketing e-platform. Okay, so we might might go over that today or next week. We have a little bit of a leeway, and that would be under here. This is a frequent item set mining. Okay, and this is done over here. Okay, right. The reason I'm not promising to cover this today is because I want to leave a little bit of time for you to discuss the data set that you picked, right? So you're supposed to, everybody has, right? By, whatever, just not your, yeah, good. So you have picked your data set that you think you'll be happy working with for the rest of the semester as your object, okay? Okay, right. Now, so it occurs to me, by the way, that I said, I want to put you guys through a mindset or in the shoes of a data scientist, and we kind of use the word very loosely. So let me just spend 2 minutes on the word itself, data science. What is data science and what's data scientist? Now, obviously, we're doing data analytics, right? We're going to analyze data to make some kind of prediction, some kind of insight, right? We talk about this kind of intelligence, where intelligence is understanding what your enemy is doing, understanding what your client is doing, predicting the weather. Intelligent means a better solution of how to ship things across a logistic network and all kind of stuff, right? But those, in the old days, those guys were just called quant analysts, right? Okay. So what makes someone a data scientist? What's the purpose of this job description? By the way, it's a new job description. Okay. There was no such thing as data science when I was your age. Well, just to be a little bit cynical, as you know, before I semi-retire and became an academic, I was in a commercial sector. I was a first senior vice president of quantitative models and enterprise analytics at Siam Commercial Bank, which is one of the top 4 bank here in Thailand, the purple one. And from my perspective, when I started the quantitative models and enterprise analytics unit, my staff were quant analysts. Okay, in fact, that's what they were. They were quant analysts, and so one day they became data scientists. Same person, exactly the same person, but new HR policy. They became and what that enabled me to nearly double their salary. That was just that, okay? But they ended up doing exactly the same thing they were doing a month before. Okay, so they were doing the same project and exactly the same thing. But when they were called data scientists, the salary just shot up. So that's not that obviously is not the definition. Okay, that's not the definition. Definition is not a highly paid quant analyst. Okay, but that's what in the HR world, that's what it came to. Well, I want to ask you, what do you mean by data scientist? Why is it a data science? Why is it not engineering? Well, you should know this because you're actually in a school of art and science, right? Well, what's fundamental about science is that there's a basis for rejection. That's it. Okay. Science actually doesn't necessarily reveal truth. It can reveal falsehood. But the point is that there is a very objective way of rejecting things. Okay. So if, you ask a girl out for a date and she say, oh, no, I don't want to. It's emotional, right? There's no rhyme or reason why you get rejected. Right. But in science, if I say y is equal to ax plus b, there's a very good, solid, verifiable, objective way of saying no. Okay. And that's quite important. Most of you guys think science is about saying what is correct. But science is actually about saying what is rejected. Okay. It's a scientific process of making things rejectable. Okay. And funnily enough, and to be precise, okay, I want you to guys to be a little bit more philosophically minded. Science never says something is true. It just says that so far, nobody has managed to make it false, to prove it false. right? That's what it is. That's what a scientific process is. But once something has been established false, then hopefully everybody agrees, right? Everybody agrees. Now, there's also agreement on the positive side, but that's like saying, but virtually by the fact that because nobody, the best mind in the world cannot falsify this statement, we might as well take it as true. Okay, so yeah, so you can say that in practical terms, science does say what is correct. Okay, but fundamentally, it's a solid way of testing whether or not something is wrong. So that's the first thing you have to understand about science. Then you have to understand that science comes in, let's say, two flavors. Okay, two flavors of proving. One of it is proving vis-a-vis the logic of mathematics or logic of a theory. In other words, if you take this baseline axiom to be right, you can derive consequence from it. Anything that's against that is proven wrong. And then that's kind of like theoretical science. Then there is another flavor of science. This is where the evidence is not from the certainty that you get from mathematics. Evidence you get from trying with real things. Okay, could be rabbits, could be Bangkok traffic, could be internet scrape data. So this would fall under empirical science. There is a basis, but even that basis is a little bit debatable, right? With mathematics, when something contradicts the logic, you know it's wrong. Okay, with empirical science, it's wrong because based on this huge data set, it's wrong. Now, that is as good as it gets until that day. But if somebody came tomorrow with a bigger data set that's even better, covers more cases, right? And it's cleaner, it's a bigger data, it's better data set, and it say, based on this data set, I can't reject. Then you go back to to ground zero. You can't reject, you can't falsify that. Okay, so with data, with science, that's empirical. It's a little bit like that. Now, question: what flavor is data science? By now, I've given you enough hint. You should be able to tell me that it is not theoretical science. It is empirical science. But that's not the main point. The main point is that data science is not about building a model. Data science is about testing, right? So if you call yourself a data scientist and you are very good at going to GitHub and taking down some algorithm and building a neural network or deep fake or all kinds of stuff, you may be excellent at what you're doing. You're still not a data scientist, right? Because your work is not really falsifiable. Okay, you just create something really cool. That's fine. That's perfectly okay. But that's what I want to stress, that a data scientist is a little bit beyond that. Now, what standard do I hold you to? I hold you to standard of data analytics. Okay, which means, for some reason I can't turn this thing off. Okay, just turn this off. Okay, which means it's not about you going to find empirical data to test some hypothesis about how the world works, but it's about getting useful insight. So you're not quite, when you, let's say you finish with this class and you go on and you practice deeply all the technique that I show you, except 10 times better than what I show you, okay? You still would not be data scientist. You still be data analyst, okay? But when you are doing analytics, I want you to do it with scientific mindset. In other words, before you hand over that algorithm to your project leader or to your client or your customer or whatever, you test. Okay, that's what makes me data scientist, because somebody asked me, okay, in fact, that's what I do now. I said I semi-retire, but I take on consultancy projects. So I build model, right? So if I build model and it's just handed over, I'm doing data analytics, but it's a lousy way of doing things because there's no testing. Okay. And so testing is the ultimate proof. Proof is in the pudding kind of things. And remember, I did tell you that data people who work in this area come in two variety. Some guys want some simple algorithm because it's easy to do. Some guys want extremely difficult, complicated neural network model because it's cool to do. Okay. When I tell my staff, you don't like simplicity because it's simple. You don't like complexity because it's complex. What I mean is that simple and complex are just options to experiment. And the proof is in the pudding, right? So I do this for all my staff, from the simple linear regression all the way to complicated, say convolution neural network. If they're actually doing the same job, I would have them on equal footing, right? And the test is in terms of performance. Okay. So yeah, in the end, it's something practical, but yeah, there's something scientific. That scientific is in the testing, in the way the data does or does not correspond to your model. Okay. So if the model is better, it's more consistent, that sort of thing. So there's a litmus test. So again, it is science in the sense that there's some criteria for agreeing that, yeah, this is bad, this is terrible, this is not how the world works. Y is not equal to ax plus b. Okay. But if I give you y is equal to dx plus e square, and it looks better, then until somebody comes up with something better, yeah, go with that. That sort of thing. Okay. Fine. So it's cool to call yourself data scientist and you get paid more, but you have to act like it. So let's go back one step to data analytics. Again, data analytics that, in this mind map that I think I gave you, right? It's not all building models and regression. Sometimes you just get insight just from looking at things, right? So just now I was showing you that I can separate the shares and the cars and cats, right? Right. That's obvious because you could see with your own eyes, car and cats, right? But let's imagine instead of having exactly that, I have a whole bunch of numbers. Okay. A whole bunch of numbers that correspond to countries. You know, what country is close to Thailand right now? Well, it's always been, Myanmar to the left and Cambodia and Laos to the right and Malaysia on the south, right? That's geographically how close we are. Now, if I did the same exercise I was talking about you earlier, I take Thailand's GDP, industrial output, maybe something like capacity utilization number, inflation trends, all kind of economic. And then I take this, okay, 30 statistical numbers representing Thailand, 30 statistical numbers representing all countries. I do exactly the same thing. And I watch the picture. Maybe it turn out Thailand is not close to Myanmar at all. Thailand can be close to Chile. Okay. Now, if I don't do this, I take other statistics that has to do with health service, healthcare. All right. Has not to do with economic, but about emotional well-being. Maybe Thailand could be closer. Hopefully, Thailand would be closer emotionally to Bhutan or something like that. Okay. That'd be nice. Okay. So happy country, that sort of thing. So again, that example, the reason I keep talking about it right now is because even though I haven't told you explicitly, it's a bit of a mix actually. You're doing the visualization, but you're actually doing some algorithm under it. So it's not visualized in the sense of take a data and just plot it, right? There's actually an AI driven, there's a model driven to that visualization. Okay. So when I say visualization, do not think I'm talking about making an Excel plot or something like that, right? Okay. Although having said that, that's a big chunk of your daily lives. By the way, I produce so many, again, when I finished my PhD, I worked for the Bank of Thailand, which is not, I must have created hundreds and hundreds of Excel charts. So don't knock it. Professionally, it's important. Okay. But while I was doing that, I was doing it in Excel, so none of it was interactive. Okay. Okay, let's talking about visualization. Okay. So this is again learning the tools at the same time. What's this? At visualization, distribution. Okay. You done statistics, right? Probability statistics. So you know just a little bit about probability distribution. I'm not going to cover that. But let's say all I do is this. Okay. Let me show you this. Now it looks like a lot of line, but I guarantee you there's only one thing that's important here. Okay. This is all the action. Everything else is formatting. Okay. And then this is going to, I want you to start, well, to learn programming or doing things, you start by looking at things that somebody already created, right? It's like learning how to make souffle. You start eating souffle and looking at bits of it. Okay, so let's read this. Okay, what am I doing? What am I doing? Okay, what am I doing? Look here. Binomial distribution. Again, this is functional programming. You communicate everything to your computer through the notion of function. Function would be the name of the function and then the argument, the x, f of x. Okay, the name of the function is called binomial distribution. Okay, I happen to know it's called that. I've done it 1,000 times, let's say. Okay, but if you don't know what this is, you can press F1. Oops, sorry, F1, not one. F1. It will take to your help page what this function does. Okay, so this is very detailed. I'm going to start from the very baby kind of step. So if I didn't know any better, I would go to this thing. This thing would say, what is that function? That function expects what? Again, function f of x, right? What is the x? It expects two things, n and p. Okay, that's it. There's only one version of this. There's only one version of this. Now, some other function has different version. Let me go to normal distribution. This normal distribution has two versions. This one expects mu and sigma. This one expects nothing. Well, when it expects nothing, what it means is that there's a default. Okay, and that default corresponds to the most usual way people work with it. Most of the time, when I say normal distribution and I don't say anything further, what should you assume? Standard normal. Standard normal means mu, yes, but that's equal to 0. Sigma, yes, but that's equal to 1. So this is the same thing as 0 and 1. Okay, so that's now with binomial distribution, there's no common parlance of what the standard normal binomial distribution is. So you have to put, we have no choice. Okay, and that reflects that. So that's n, that's p. Okay. Now, this is a kind of function that doesn't produce anything yet. It only declares your intention. My intention is to work with binomial distribution. Binomial distribution, as you know, is what? Come on, it's a review. If I toss a coin with probability P, okay, of landing a head, okay, probability P of landing a head, and I toss this coin n times independently, the random variable that comes out, binomial distributed random variable, is the number of times that landed head. So if I toss the coin n times, can I get n plus 1? I can't, right? Can I get minus 1? No, I can't. I can only get 0, no head, 1 head, 2, 3, up to n. Right? Now, as you know, probability of all 0, if you throw 100 times, it's going to be very small. Okay, it doesn't matter what probability of 0 is. Okay, same thing with probability of 1. Let's say I have a probability of 1 of 0.9. Okay, that's a high number, right? But the probability of getting 100 hits in a row, that's still going to be pretty low. Okay, so what do you expect? You expect that the distribution will have this kind of, yeah, exactly, right? But so far, I haven't said anything. I only said I intend. So this function, again, functional programming paradigm, all I'm saying, I'm communicating to my program, sir, ma'am, I intend to work with binomial distribution. Okay, that corresponding to tossing a coin with probability head of 0.2 50 times. Okay, just for some reason, that's what I want to do. Now, what do I want to do with it? Actually, I want to generate random variate, meaning I want the computer to come up. So don't draw me a nice picture of a normal, a binomial distribution that you see in the Wikipedia page. I don't want. I want real number. You generate. You generate. You come up with it, right? And I want how many of them? N points. That's the number. So that becomes a free parameter. Again, this could be a free parameter. This could be a free parameter. Now I put in the number. It's fixed. This one happens to be free. Okay. So I'm going to generate this. I have the option of how many points. Once I generate those points, how am I going to visualize them? Well, I go and visualize histogram. Okay. So this is going to look, the more sample I have, the more it's going to look like the theoretical nice picture. But, you know, if I generate 5 points, it's going to look a little bit, you know, jagged. So this happened to be, okay. And I happen to have, okay. Now this 2 parameter serve this function. This is an input. This is an input to that function. Okay. So now we have two bivariate function. This function takes 50 and 0.2. This function takes a parameterized distribution name and number of points. This function will happen to take a lot. It takes 1, 2, 3, 4. It takes 4 arguments. And this is one of those things where if you go to F1, sorry, it's going to have many versions. Okay, it's going to have very versions, but never mind. Okay, so histogram, well, it's just exactly that. Histogram, you do that in Excel. Comma, number of bins. This would be some kind of like preferred number of sticks. Right now, obviously, if there are actually 5 different values and you want 10 different sticks, it's not going to give you that. So it's you want it. You want that many bins, but it may not have that many bins. Okay, so it's just a suggestion. And maybe this is a type histogram that I just add this. So actually, you know, I could have just stopped. All this is actually optional, meaning that if I didn't put in n bin, it's going to come up with something. And then I put in this one, even more function. And this is kind of like picture pretty, make it look pretty. Chart element function class rectangle. This is just to make it look pretty. Okay. I could erase this and I could erase this. Now, so this is the action. What's the action before that? Seed random. Now, seed random means that I want random, but I want repeatable random. Okay. I don't have to do that, but let's say I do that. So every time I do this, I'm going to get the same sequence. Okay. Now, what are the parameters I can play with? Well, this parameter is an argument for manipulate. Okay. So see how everything is put in terms of function, but it's not restrictive because you don't have to put numbers. This function requires number. This function requires a name and number. This function also like that. This function requires action and buttons, tweaker, things that you tweak. What do I tweak? Well, let's say I want to type histogram. There's automatic, meaning, you know, default. So another word for default. Cumulative count, PDF, CDF. Okay. Number of points. I just happen to make this up. Okay. Just an example. Number of points from 200 to 2000 instead of 200. We did this already, the iteration. Number bin 5, 50. Okay. Control placement, face and top. So I did this. Okay. So there, it looks nice. Now, I don't know if it looks nice, but certainly the control is on the top. If I didn't do this, I think the default is on the left. Yeah, it's on the left. Okay, let's leave it on the left. Fine. Maybe on the right. Yeah, that's better. Now, notice this thing, type histogram, that's my button. Endpoint, that's my endpoint. End bin, that's my end bin. So number of bin of my preference, I can make it, okay, more detail. Okay. Number of points, obviously I generated 200, right? This is not very nice. So let's make it, okay. The more I generate, the nicer it is going to look like in the classic page, right? And what do I want? I want automatic cumulative point. Oh, cumulative, just, you know, like a CDF version. Same thing. Okay. So that's how I visualize. Now, this is how I want you to present your graph. When you were in high school, how do you represent your graph? You have an Excel, you choose something, right? Number of bins, you choose whatever you want to display, you generate the graph, and then you capture that picture, you put that in your PowerPoint. Okay. Now, if this were to be my PowerPoint, this is what I would do. I would hide the code. I would hide the code because, you know, I want to show, right? And I would just go to this here, palette and slideshow, go to slideshow. And here I just happen to say view slideshow. Okay. So this would be something like PowerPoint, except, okay, go to the next page. Well, I only have one page in this case. So normally with PowerPoint, you go from one page to the next. Again, it's very linear. Oops. For some reason, this thing, oh, yeah. So this is my PowerPoint. This is like my PowerPoint, right? I go to the next page, I have this, but I happen to have just one page. But now when you present this to your client or whatever, right? And your clients, and by the way, this is a little bit funny, but when I was your age, this happens a lot. You present this to very senior management, and they happen to not like the way it's presented. They literally will ask you to redraw that graph and send it next time. And if they're nice about it, they'll say, just send it to me later. If they're not nice about it, they'll say, I don't want to hear from you anymore. This graph doesn't look nice. Go make a better graph and come back next week. And then, you know, you prepare this thing and then you go for 2 minutes and then you get knocked down and then they go to the next meeting agenda. Okay. Well, now you don't have to do that anymore. Well, you don't like cumulative count. You do this. Okay. You can, you know, so it's interactive. It's interactive. Okay. Now, there's a lot of tools now. If you all you want is interactive, there are a lot of separate dedicated tools for interactive plots. For example, have you guys heard of Tableau? Tableau is one of these. Tableau is one. It doesn't do anything else. It doesn't do calculus. It doesn't do machine learning. It doesn't do anything, but it does this. What else? Power BI, I think. Okay. A lot of business analytics are a little bit like that. Okay. Remember I told you about business analytics, business intelligence. Business intelligence is about information that's hard to find. So when you go to business intelligence software, what it doesn't mean is how do you get those intelligence data? It means just how to display them. Okay. So when you search for things like business intelligence software, it's kind of like it's cheating a little bit because it's not helping you find the business intelligence. It's just helping you display them in a interactive way. Okay. So it's not really business intelligence tool. It's more like interactive plot. Okay. But now, you know, with this, you just use this, except you can be more. Okay. So again, slideshow. Let's go back to working environment. I don't want to view. Let's go with working. Okay. Now, so I if I double click this, it shows the code again. Okay. So there's so many things you can. By the way, you know, how many other options? Just go F1, and there's, you know, a list of other options. So class rectangle, rainbow. Okay, let's go rainbow. See what rainbow that's like. maybe rainbow doesn't work here. Oh, because just arrow rectangle, maybe, I don't know. Okay, these are some options are suitable, some of it's not suitable, and so forth. Okay, was it? Okay, well, I'm just gonna erase it. Okay, so it becomes just a yellow blob. So now it's not that pretty, but it's quick. Likewise, this is something very useful. It's called paired histogram. Okay. Again, this is not, it's something you can use matplotlib and just draw one picture, rotate left, rotate right, put them together. But this is kind of like a boilerplate. If you do this all the time, you just sort of like want to have a built-in function. So this happens a lot with demographic data. Why? Because it's boy and girl, right? Boy on the left-hand side, girls on the right-hand side. So this is kind of could be some kind of age distribution, sometimes called violin plot because it looks kind of this. Okay, so again, I generate this, so that's not that interesting. Okay, but certainly I can get real data. So instead of generating it, I can use a real data to plot, because histogram and so forth. And I can plot the left hand side. So instead of having the data that I generate here, I can just literally draw a data from CSV file to show that. This just happened to be red and green, so color doesn't matter. So a lot of this, when I'm going to give you the workbook, by the way, right? If you see this thing in the comment, chances are it will be the URL where I get this example. Okay, so copy their homework. So this is kind of like a fancier way. So you're not just drawing the random. By the way, random integers is naming a random variate, except random integer works for discrete only. Okay. So create a whole bunch of them. Make a histogram. Okay. Actually, you don't need to make the table first, but yeah, in this case, chart star happened to, I don't know what that is. I just copied it. When I put in yellow, that means I copied the whole thing. So don't ask me all this. Okay. And it's just very nice, right? Just move. So you have superimpose. What would and this is how you would do the data, by the way. What I tend to do is this. If this were the real life, okay, the stack that you see would be real data. The stack that you see will be the real data. The curve, the smooth line that you see would be the fit. And I would show simultaneously, right? And this immediately, right away, tells you right away how well the data or the model fits. Okay, and that's a whole bunch of stuff. You play with this. Doesn't matter. Sometimes you want a point. Sometimes you want a line. So filling to axis. This is. And in my application, the one that I use in real life, say professionally, instead of just one line, I will also have a lot of lines. Except those lines are not like, like when I told you that in Python to do one thing, you need 50 lines. In this case, additional lines are just window dressing. Make it pretty. I want this color green. I want that black. I want this small. I want this large. But the real action, just like this function here, that's it. That's all the action there is. Okay. So you can use this as a starting point. And in fact, chances are, again, ideally, you go home tonight, take this and look at the data set that you picked from last week and see if you can represent that using this thing here. So this is a little, oh yeah, the male and female. Okay. Right. So this is some of, you go to data repository, but for my class, sometimes I don't go to a real big data set. I just use data set. So these are some kind of like example data. So example, and this is how I would do. Let's say I just list example data. What have I got? Oh, whole bunch of things. There's arrow image. So these are kind of like family. Okay. So if you go to this, you'll be a lot of sound file. You go to here, there'll be network graph. Like I think somebody was talking about the connectivity between a jazz player. Is that you? Okay. Matrix, machine learning, all kind of stuff. I think, okay. So if I highlight this, I just take statistics. Where's statistics? There. This guy. and go example data statistic, I get a bigger list. This is kind of going down now. So apparently, this was an example. What was I doing? Oh, I was looking at statistics, Old Faithful. Okay. So you can copy it. So again, this example data is a function built to access example data. Okay. So we can put in, so if you put in something like example data, it say, okay, what have you got? Once I got this, I want to focus on statistic. You put in statistic. Oh, what have you got? There's some statistic on cement heat, statistic on ceramic strength. I think I picked statistic on Old Faithful. Old Faithful is a geyser. You know what a geyser is? It's a hot steaming burst of water, right? Now, so I got this, comma. What do I want? I want to look at column heading. This would be like the first line of each data set. Okay. So what has it got? Oh, it's very simple. That I know why I picked this data set. It's so simple. It's only got 2 lines, right? 2 column. Okay. Duration and waiting time. You guys know what that is, right? Well, in a geyser, it's not just continuous stream. You have to wait a few minutes, and then it shoots. And then duration time is how long it lasts. Okay. So it's a water show basically, right? So to give you a, well, let's go through that. So I load this. Now the grid here just say I want 4 things: left, right. Okay. The real action here is this: list plot. List plot, just as it say, it plot the list of things. In this case, it's a list of recording. What do you record? Go Old Faithful. How long do you wait? And how long does it last? So it's 2 numbers, right? And so this is list plot. This is density histogram. This is histogram 3D. This is smooth histogram 3D. So these are different version of things. So I did this. Okay. Now, this just shows you that these are 4 different kind of plotting you can do. And so essentially, I think, was it waiting time and duration, or duration and waiting time in minutes? So right away, I know why I picked this data set. This data set right away tells you the insight. Okay. Now this is insight. It's simplistic, but this is exactly what data scientists do. You see this, and even before you do any kind of fitting, I'm not fitting anything. I'm just plotting histogram, right? Can you tell me anything about the Old Faithful geyser? Just look at it. There are 2 types of explosion event. One around 2 minutes long, but they're sort of like, on average, you have to wait about 50 minutes to 6. So if you wait an hour, you get about 2 minutes. On the other hand, there's some time occasionally when you actually have to wait a long time, like 90 minutes, but then you get longer. So based on this alone, you can think, without knowing anything, maybe there's a structure in there. Maybe, well, how do you get a geyser, by the way? Water, hot water gets filled up in a cavity, right? Once it gets to a certain pressure, it can't hold it anymore, right? So what would you say? I would say that there are 2 sides of cavity here. There's a cavity that's larger, takes a longer time to fill. But because it takes a longer time to fill, once it shoots a bit longer, right? So this is what we call bimodal distribution. Bimodal, not because it's 2-dimensional, but because there are 2 peaks. So there's a little peaks here and there's a bigger peak. So you can see, right? Now, let me show you something else. Instead of doing this, I can use manipulate. Let's do manipulate. Let's do exact same thing, okay? And I'm going to do manipulate, right? Instead of putting in a grid where I show all 4 styles, I'm just going to say, I'm just going to do this. Okay? I'm going to say, plot this way. Okay, I'm going to say plot this way. Okay, and then I put manipulate around it. Okay, again, and this is the action, and manipulate has two. Okay, by the way, if you notice, once I put in one thing and I put in a bracket, there's a red cursor. Can you guys notice that? It's saying that it's expecting more. Okay, you're not done. You have to give me one more thing. So I'll give you one more thing. How do I specify? So I say, and this is a set. This is like a table. So I put in bracket, plot this way. And then the option. What are my option? My option would be list plot, comma, density histogram plot, comma, histogram 3D, comma, histogram, smooth histogram 3D. So, okay, boom. Wow. Not pretty. So let's put control placement to bottom, I guess. See? Now I choose. Okay, right? So this would be like, again, when I was using the Excel, I showed this graph, and the senior executives say, I don't get it. I don't see it. I would rather see on top. Okay, like a contour plot or something. Okay, so come back next week. Well, I don't have to come back next week. I can just go contour plot. Yeah. Oops. List contour plot. List contour plot or contour list plot. Okay, or something like that. Okay, maybe this is better, or okay, apparently not. Okay, so I can do this. Okay, so it's interactive, and okay, by the way, you can do this obviously because it's a 3D object. Okay. Now you will learn how to do this in Matplotlib as well, because again, some of you will go into professional data scientists, and this is a cumbersome but universal way of plotting that we like a Matplotlib. So this would be a visualization of a distribution, right? Visualization of a distribution. Now, let's go visualize location. Again, this would be like if you were to press equal to look up Thailand, right? And then you get some data from it. And in this case, I think I've already got data. Yeah. So again, you see this kind of thing. It's kind of like special highlight. So it's not just a variable. It's not, it's not like Thailand equal to 5 or something. Okay, that would just be a black letter. Okay, but in this case, it's associated Thailand as a country. Just like before that, you saw Buzz Aldrin, and then there's a faint line that say astronaut. So you know it's the same guy. So in this case, I happen to put your list plot. Again, list just means it's not mathematical function. Okay, there's a good word to remember. If I use plot in Mathematica, it usually means you have to give it mathematical description. If you give it list plot, then you have to give it data. So that will be the okay. But you can always search for function. Okay. In this case, it's geo because it's geographical data. List because you're actually getting a real number from data. Plot, and in this case, I put bracket here to make a list because I want to plot 2 countries. Happens to be Thailand and Indonesia. Okay, and plot style I just make blue. I don't know why. Okay, but again, this is something I wanted to do for my interactive textbook. So in my earlier thinking, maybe this would look nice, so I put it blue. Okay, so that's the output. Okay, notice I haven't. By the way, this is from a safe notebook, so it's got this already, but it's not active. So this thing doesn't have the number. This doesn't have the number. So now when I enter it, 28. Okay. Now it hasn't done. It's running. It's running because it actually has to go to the internet to get this data. It's not something that's stored locally. output 28. So now it's a real picture. And now I can export it. I can, there's obvious a lot of different way of projecting. You guys know that, right? The map is two-dimensional projection of the 3D surface, right? It's actually a 2D surface on a 3D manifold. No, it's a 2D manifold in a three-dimensional space. I think you say something like that. Yeah. But the point is that you can only have 2 degrees of movement, up and down. But that up and down is embedded in something bigger in 3 dimensions. Okay. So you need some kind of projection. So this is all distorted. Depends on how. So I think if you go to F1 here, then you would obviously have different projection method. Okay. So this is all flat. This is all nicer. So maybe some kind of background is relief matte. Okay. Oh, let's look at that. Let's see if that's nicer. But I think there's also option on like projection or something like that. Okay. So usually, invariably so let's say instead of having a plot star blue, I just say let's see that. Because underwater it would just take superimpose underwater picture. So it's picking Thailand, highlights a little bit, and Indonesia, and it's showing the relief map rather than just blue. Okay. Oh yeah, I did this, right? So geolist plot, Chulalongkorn Mahavidyalay. That's good. I think so. Suvarnabhumi. So Chulalongkorn to Suvarnabhumi. So that's map. This is also, again, if I shift enter, it's going to take a few seconds because it has to go and look that up in the internet. There you go. Okay. So Suvarnabhumi. And then once you got this, you can actually put in something like a shortest route. Okay. Now, how would I do it? I don't memorize all the function in Mathematica. So this is where I actually use Google. Mathematica, find shortest route, find shortest tour. Okay, so this is shortest tour on a graph, shortest path. Okay, it's on a graph, but on a map, shortest route on a map. Geopath. Okay. Geopath. Okay. Just now it would work if you have a network. Say, for example, shortest path for me to travel from Miles Davis all the way down to Louis Armstrong. Well, actually, that's probably just one path. But let's say, some unknown Thai jazz musician who's played with this guy, who's played with that guy, who's played with this guy, who's played with that guy, who's played with Louis Armstrong. Okay. What is the shortest path? And that you would use that. Okay. But here is geopath. Geopath is geographic. So there. Oh, most of the time it's airline. Okay. Okay. So this is all geopath and find shortest tour. So I still use Google because, I can search over the Mathematica help, but I do this because sometimes it actually goes to a user group and they have a little nice suggestion. This is a built-in model. So, right. So, visualization. So this is about visualization of, again, this is example. This is the one I should have shown you. Okay, so this is not mine. I just copied from this page, from a tutorial page. What does it do? Countries. Where do I get countries from? All the countries in United Nations. Capitals. Where do I get it from? Well, I look up the entity values of the country and I go capital city. By the way, this is still blue because I haven't entered it, right? So let's say it's position. I get position of the capitals. So now I have a distance and a permutation of the shortest tour. That this is where it becomes like a Louis Armstrong to whatever. Okay. So geographic, show the path from this. Okay. And I think I make it red or something like that. I don't know what that is. Oh, this is what I was telling you earlier. Geo projection is an option. So right now, I don't want a flat map. I want the map that looks curvy. Okay. So center around 0 and 90. I would imagine 0 and 90 would be longitude and latitude. Range the world. So this is, again, I copy this example, and you can copy my example, copy other people's example. So it's running. This might take a bit longer. Input 31. Output hasn't come out yet. So wait a second. Okay. So this is basically creating your data set, right? And this is your plotting. This is your main action. Oh, see, it takes a while to download geo file. There it is. Okay. So these are all the countries from United Nations. So it even includes some small island nation, and find the shortest tour that covers, right? And because it's center, why is it? Oh, center at 0, 90. So I think that's Asia. Okay. 0, 0 would be the meridian here. Okay. So 90, I guess we are kind of 6 hours, 7 hours ahead of Greenwich time. Yeah. So that's about right. That's about right. Yeah. Because 90 would be 90 degree. So that's about 6, 7 hours ahead of Greenwich. So that's about Thailand. I guess. Yeah, obviously, I think that's why I chose this. I chose Thailand first. I think if you go to this example, it probably centers around United States or something. You can change it a little bit. Something. So this is the same thing. Now this is fancier. The reason it's fancier is because instead of just saying that it's fine location, it's finding geodistance to find the circumference, as if you're flying a small airplane, and your small airplane has a range, right? It's not a big jet, so it cannot fly for like 3 hours at 120 knots or something at best, with some safety fuel. So this is kind of like this is a toy example of, okay, if you're from here, I think, this is how far you can go, blah, blah, blah. Okay. And, so there are other things. So I think I didn't even bother copying this. I just put in the HTML. So let's see what it's there. And sometimes I try to like spend a few weeks, writing the text, and then I go away and I forget about it and do some other thing, and I forgot what I did. So this is one of those things where, why do I think this example is interesting? Why do I think this example is interesting? Okay. Okay. London. Anybody from London or been to London? Okay. Fine. So this is actually, okay. And it shows you the code. This is a tube underground station. Yeah, this is underground station. This is what's called Circle Line. This is semi-geographical. If you look at the London Tube, so for example, I'll show you. This is definitely a South Kensington station. I went to Imperial College, so I have to get off here and walk a little bit there, past the Science Museum. I lived in Elephant and Castle, so it was here. So if I was to take one stop up there, take the Circle Line, come up here, and go to Leicester Square, eat some Chinese stuff, rice, and I go work in London. I was an intern student at Chemical Bank, so stop at the bank station. That's a big station there. You can also bicycle, stuff like that. So here, once it becomes a node and a line, you can literally do a route planning, so you can find shortest path and all kind of stuff. So, okay, well, obviously you do that in your head when you're traveling in underground London, but let's imagine, right? You can imagine this. Okay, that's even better. What if you have a more active, dynamic map that tells you how long a delay from here to there? So it's not just number of station, right? But it's number of station takes into account how long it takes from one train to the next. And sometimes there's some delay. So even though the train can go really fast around, say, Leicester Square, usually trains have to wait for one another. So they go slow. Okay. They don't exactly stop. I think they just go really slow. So you can do this and say, well, from here to here, maybe it's better to go this way. Occasionally, it's a lot better to go long way, get on, I don't know, somewhere in the east end, and just take a circle line way out here and come back faster. Okay, and that happens in logistics. So this is visualization, but again, if the object has the data and you can compute on it, you can compute on it. But today, still strictly speaking, today we're talking about. Now let's take a break. But before I take a break, let's add one more thing. There's okay, so this is visualization, just simple plot, right? This is geographic. Another thing that's useful and happens a lot, very useful, more useful than you think, is timeline. Okay. Now this I happen to again I copy this. So this is kind of like timeline. I guess this is birth and death. Is that right? Yeah, that makes sense. So these are all the romantic composer, right? So you usually stop classic period at Mozart and you start romantic period at Beethoven. I guess you end up with Liszt or something. Yeah, Dvorak. So Beethoven, Schubert, Liszt, Wagner, Chopin, and Dvorak. Okay, birth and death. You can also so this again. If you look at the programming line, you see that it has a lot of lines, but there's only one or two action line. So the action line is just like timeline plot. That's it. There's one action line. Everything else is all pretty up. Same here. Timeline plot, and just make it pretty. Oh, let's make it from plot label, plot name, start bubbles, and so forth, and blah, blah, blah. Okay. Now, this is timeline. Timeline, strictly speaking, is usually used for historical event and when you give a context. You know how come Liszt is influenced or the style of well, you say, well, Liszt is kind of like born right here, so obviously he's very heavy, very dramatic kind of guy. Okay, so if you move further back, it's more clinical. People like Mozart, you go all the way back to Baroque, it's almost like a formula. Okay. And then you go further down here, you get something really weird, get Schoenberg and whatnot. Now, here would be what I expect, maybe not half, maybe a third of you, hopefully. Maybe my guess could be wrong, okay? I'm guessing that maybe a quarter of you from last week's example picked up some time series data. And this would be how you work with it. And this is kind of like stock price or something like that, time series. Okay, so basically dates and once you got this, then you can do time series model. Okay, so let's do Google search for guide, say Mathematica time series analysis. If you go to time series plot, you probably. So yeah, so there's actually video. Okay, time series processing, and so. Oh, this is kind of part of the ad. I guess you can do some kind of directly perform. So you time series. You can put filter. I don't know how many of you are actually interested in financial markets, like traders. Maybe you have some of your friends working. My life, I spent maybe a good half of my professional life dealing financial time series. Okay, so this is something that's a lot closer to me than it is to you guys. But basically, time series just looks like a big, quickly thing. And it does not make sense until you put in some filter, like smoothing filter. Then it starts to make sense. Oh, there's a trend there. There's a dip there. There's a, that sort of thing. Okay. So the idea is you get a squiggly dot line. Okay. This is a whole time series analysis, by the way. It's a little bit like this. You have something that is predictable, like an underlying trend, and you have the squiggly. So you want to predict not the squiggly bit, but you want to predict the smooth bit. But it's always impossible to tell backward. Well, backward you can, but it's impossible to tell forward which bit is the squiggly, which bit is the real trend. Right? So in this case, you can say, oh, I can put a sine wave. Look at this. See, I can put a sine wave here. Woo! But maybe sine wave is too naive. If I put in 2 or 3 sine wave, I can pick up this thing. Okay? Now, if I'm going to trade on a daily basis and this cover a year, that's still too crude. So there's always a balance of how details you want to fit. Okay. You can always fit every single data point, but that's not what you want to do. Because if you fit every single data point, you're fitting noise. So it's always noise versus signal. In engineering speak, it's called signal to noise. Except in engineering, life is easier. Why? Because you know what's signal, what's noise. Signal is what comes out when you make it. Noise is when you send it to a wire and receive it, and you take that and you subtract this. That's your noise. There's a very clear definition in engineering, right? My voice is perfectly clear. It's a signal. What you hear through the amplification down is plus noise. So you take that minus what's happening here. That's your noise. Okay. In time series, in financial time series, it's all squiggly. Okay. What's the signal? What's the noise? It's very hard. Okay. So it's a little bit of art. So that time series is in there. Okay. So with that, let's take a little, visualizing flow. I haven't done any example, so I'm gonna have that here. Okay. Have I done connection, visualizing connection? Oh, this will be big, but I haven't done it here. So, okay, let's take a break.